So our main topic is about intermolecular forces, and basically these intermolecular forces are forces which exist between the molecules of covalent substances. We are talking about the covalent compound. So before identifying this, as we know, a covalent substance or a covalent compound can be a non-polar covalent compound, means not affected by electric field, and it can be a polar covalent compound. A polar covalent compound is affected by electric field, or electric field affect the compound. So the intermolecular forces means, like example, if I say an example of a non-polar covalent compound, it can be methane, it can be hydrogen molecule. So methane is example of a non-polar covalent compound. So this is one molecule of methane, and there is another molecule of methane. So when we discuss the forces between them, between the molecule, like this is one molecule, and this is another molecule. So when we talk about the forces between the molecule, not within the molecule, but forces between the molecule, what we call that force, we call that as intermolecular force. And same way, if we have a polar molecule, example, there is chloromethane. A polar molecule will have a net dipole moment will be there. So this is one molecule, and there's another molecule. So these are the two molecules, but these are polar molecules. The force of attraction between them, the force between the molecule, is also known as intermolecular force. So what kind of intermolecular forces exist in a covalent compound? So there are three types of intermolecular forces. So the intermolecular forces between the compounds can be, and it's for covalent compounds, so it can be dipole induced dipole, or also known as London dispersion forces. It can be dipole-dipole force, or it can be a hydrogen bond. So these are the three types of forces which can exist between the molecule. It might have a dipole-induced dipole or London dispersion force, or also known as van der Waals force or weak van der Waals force. Another one is dipole-dipole force, and the third one is known as hydrogen bonding. How you can identify what kind of force or effective force, like, and in a within the molecule it might have dipole induced dipole force, it might, as well as it might have dipole dipole force, like two of the forces might be there together as well. So it's not like if we have two molecules, if there is a hydrogen bond between them, they don't have dipole dipole force. No, it may have one of the force, it might have two forces, or it might have all the three forces in the molecule. But the force which is effective, that depends on certain factors. So if we have a non-polar molecule, then when we have a non-polar molecule, then the effective force will be dipole-induced dipole force. Whenever you have a non-polar molecule, when you have a polar molecule, the effective force, it will be dipole-dipole. And when you have, what is the meaning of hydrogen bond? When hydrogen is bonded with three of the elements, which is fluorine, oxygen, or nitrogen, any one of them, hydrogen is forming a bond, or hydrogen is involved in a bonding with any one of them. So what kind of bonding will be there between the molecule? It will be dipole, it will be hydrogen bonding. The effective one will be hydrogen bonding. So the first criteria to identify the intermolecular force or force between the molecules, if you want to identify what kind of force or what is the intermolecular force between the molecule, you have to check the nature of the molecule. If a molecule is having a non-polar nature, like if the molecules have non-polar nature, then the force, effective force will be dipole-induced dipole. If the molecules have if the molecules are polar, like polar means they have charges on them and the net dipole moment is not zero, in that case they will have dipole force. And if hydrogen is bonded with fluorine, oxygen, or nitrogen, in that case it will have hydrogen bonding. So it depends on the type. So we'll start the topic. This is the intro of the topic, the introduction. As we discussed in the last session, the intermolecular, the first part was the shapes of the molecule and how we can identify whether it will be a polar or non-polar is by passing through electric field. So the first one, the intermolecular force, also known as London forces, and in what kind of compound these London forces can exist? It can exist for non-polar compounds. Whenever you have a non-polar compound, then the force exists between the molecule is known as London dispersion force, London force, or weak van der Waals force. And this force is directly proportional to, the force between the molecule is directly proportional to number of electrons. If you have greater number of electrons in the system, then they will have a strong London dispersion force compared to few electrons. Example, we have a molecule of hydrogen. So hydrogen share one electron. This is one molecule of hydrogen, and this is the other molecule of hydrogen. So when we check the nature of the molecule, when we work out the nature of the molecule, what is the nature of the molecule? Is it polar or non-polar? Hydrogen, both hydrogen has atoms have the same electronegativity. So both have the same tendency to attract electron. So what will be the nature of this molecule? This molecule will be non-polar. So this is non-polar, and this is also non-polar. So if two non-polar molecules are there, what kind of intermolecular force exists between them? They will try to attract each other. And what we call this force, we call this as London dispersion force or weak van der Waals force or dipole-induced dipole or instantaneous or induced dipole force, we can also say. Like induced dipole or instantaneous or induced dipole force or dipole-induced dipole force. And this dipole-induced dipole force is directly proportional to number of electron. If we increase the number of electron, the dipole-induced dipole force will also increase. So example, you have a molecule of like you have hydrogen, a sample which contain hydrogen gas, and another sample contain chlorine gas, Cl2. So chlorine is also because two identical atoms are there, they don't have any difference in the electronegativity. So bonds will be non-polar as well as the molecule will be non-polar. Like chlorine molecule is non-polar as well as the bonds will be non-polar. So this is one molecule of a chlorine. This is another molecule of chlorine. And between them, because these are non-polar molecules, so between them, what kind of force will be there? What we call that as dipole-induced dipole. So when we compare the strength, when we compare which one is having a stronger dipole-induced dipole force, so which one is having a stronger dipole-induced dipole? So for that, you have to check the number of electrons in the system. When you check the number of electrons in the system, this is having two electrons, the molecule, and this molecule also two. So total four electrons are involved in attraction. But when you check chlorine molecule, each chlorine is having 17 electrons. So a molecule of a chlorine will have 34 electrons. So there will be 34 electrons in one molecule and 34 electrons another molecule. Basically, the electrons of one molecule is not attracting the electron of the other molecule. The electrons of one molecule is attracting the nucleus because these chlorine atoms will have the nucleus. So there will be attraction between those 34 electron and the nucleus. That's the force which is responsible for attraction between the molecule, and we call that as dipole induced dipole force. And this force increases as the number of electron increase. Is it clear? The concept of dipole induced dipole force. Anyone having a doubt or a question? And the second factor on which this force depends is the surface area. If we have a large surface area, there will be a stronger attraction. Like if we say we have a straight chain alkane, say butane is there, so CH3, CH2, CH2, and CH3. And there's another molecule of butane, CH3, CH2, CH2, CH3. So this is one molecule of butane. This is the second molecule of butane. So they are attracting each other when the molecules are non-polar molecules. So if molecules are non-polar, then the force between them is known as dipole-induced dipole force. When we check for a straight chain alkane, which is example in this one butane, or if we have 2-methyl propane, so when we check, this is one molecule, this is another. So when we check the branched one, only this side they are exposed, like they're in contact with each other. It's like a puzzle, a jigsaw, so which can fit in a certain direction. So as you can see, like the area which they are in contact, that is changing, that is small as compared to when they are straight chain. So when we have a branch hydrocarbon compared to the straight chain hydrocarbon, what we'll find straight chain will have a high boiling point compared to the branch. The branch one will have low boiling point. So what is the reason why the branch hydrocarbon is having a low boiling point compared to a straight chain? Because straight chain, the molecules can have a greater surface area, they can overlap with each other, greater parts, they can attract each other as compared to a branched one. So as the number of the branches increase, the boiling point will decrease, as because the surface area is also decreasing with the boiling point. So large surface area of a molecule, straight chain molecules have a large surface area, and when they have large surface area, more parts in contact with each other, so the boiling point will increase. So always remember that dipole induced dipole force increases with Dipole-induced dipole force increases with the surface area, and it also increases with the number of electrons. When we talk about intermolecular force, when we have non-polar molecule, they will have dipole-induced dipole, or you can also say London forces. This is what I have discussed till this point. Then, what is the meaning of permanent dipole or dipole-dipole force? So, whenever a molecule is a polar molecule, whenever we have overall net dipole moment is not zero and the molecule having poles, example, say we have CH3Cl. So, partial positive, partial negative, and partial positive, partial negative. Because difference in the electronegativity of a carbon and chlorine, and the molecule is not symmetrical, so this part having a permanent positive and negative, and this is also having permanent positive and negative. So this permanent positive and negative parts are attracting each other. So as the permanent positive and negative parts are attracting each other, what we call this force, we call that as permanent dipole or dipole-dipole force. And dipole-dipole force depends on the difference in the electronegativity. Like if there is a greater difference in the electronegativity, they will have a stronger dipole-dipole force. So the dipole-dipole force directly proportional to the difference in electronegativity. So greater the difference in electronegativity, greater the dipole-dipole force. That is why, like example, if we have a molecule of chloromethane and there's another molecule of bromomethane. So when we compare the electronegativity here, because there will be partial negative and positive, partial positive and partial negative. So when we compare, as we know, as we go down the group, like fluorine is there, chlorine, bromine, and iodine, the size of the atom is increasing. So as the size of atom is increasing, the electronegativity tendency to attract the shared pair of electron is decreasing. So bromine is having a relatively weaker tendency to attract the shared pair of electron compared to that of chlorine. So when we compare the strength of the dipole force, so which one will have a stronger dipole force? In chloromethane, they will have a stronger dipole forces as compared to chlorobromomethane, which will have a weaker dipole force. Is it clear, this concept of dipole forces? So whenever we have a permanent molecule is having a permanent positive and negative, it will have dipole forces. Any doubt till this point? Then the third type of force, that is known as hydrogen bonding. What is the concept of hydrogen bonding? When hydrogen is bonded with the most electronegative element such as fluorine, oxygen, or nitrogen, we call that as a hydrogen bonding. So example, you have hydrogen fluoride, HF. So hydrogen share one, fluorine also shared one, but fluorine is the most electronegative element. So as fluorine is the most electronegative element, it has a greater tendency to attract the shared pair of electron. So this shared pair of electron between hydrogen and fluorine is shifted almost all towards the fluorine. And same thing happened here, that this shared pair of electron is almost shifted more towards or almost transferred to fluorine. So as a result, what happened? This hydrogen, it appears that this hydrogen does not have any electron in the outer shell. and the shared pair is almost taken by the fluorine, and there will be partial positive negative, and here hydrogen, it's less electronegative compared to fluorine, so the shared pair is almost transferred to fluorine, it appears. So as a result, what happened, this partial positive hydrogen is attracted towards a lone pair. So there will be attraction of hydrogen partial positive towards a lone pair of another molecule, and what we call this attraction, we call that as hydrogen bond. And hydrogen bond, the bond angle is always 180. As you can see, the bond between hydrogen and fluorine and the bond between hydrogen and the lone pair. So when we work out the bond angle, it will always be 180 degrees. So what this only happen because hydrogen, whenever it form a bond with fluorine, oxygen or nitrogen, this only happen in with these three elements. If hydrogen is forming a bond with chlorine, for example, hydrogen is forming a bond with chlorine. So chlorine is electronegative but not having a stronger electronegativity compared to that of fluorine. So still the electron pair remain between them and it is slightly shifted. But here what happened in case of fluorine, it is almost shifted towards fluorine. It's a pair like an ionic bond. So same thing, another molecule is there. So this will be partial, hydrogen will be partial positive, fluorine negative, hydrogen partial positive, fluorine negative. So the partial positive is attracting the partial negative. So what we called in that case, we call that as dipole force. But in hydrogen bond, what happened? The partial positive or almost positive hydrogen is attracted especially towards the lone pair or attracted towards the lone pair. So that is known as hydrogen bonding. And hydrogen bonding is only existing when hydrogen form a bond with nitrogen, oxygen, or fluorine. Because the condition for forming a hydrogen bond, there should be a greater difference in the electronegativity and there should be a lone pair on the atom. So as you can see in this, like we have hydrogen fluoride, the first example. So hydrogen is partial positive, fluorine is partial negative because of difference in electronegativity. And here hydrogen is partial positive, fluorine is partial negative. So the hydrogen is attracted towards the lone pair and this attraction is known as hydrogen bond and the bond angle will be 180. The other example is ammonia, NH3. So nitrogen is having a low, like this is one molecule of ammonia. This is the outline. This is one molecule of ammonia and this is the other molecule. Difference in electronegativity, hydrogen is partial positive, nitrogen is partial negative. So, and what it appeared that this shared electron between nitrogen and hydrogen is almost shifted toward nitrogen. So the partial positive hydrogen or almost positive hydrogen attracted towards a lone pair result in a formation of hydrogen bond. And same is there for water. Like we have water H2O. So in case of H2O, oxygen is having two lone pair and two bond pairs. So hydrogen is partial positive, oxygen partial negative. So this positive is attracted towards a lone pair of another molecule. And the bond angle, always remember, they ask what is the hydrogen bond angle. So that is always 180 degrees. Is it clear? And when we compare these, even though the hydrogen bond, when we compare the strength of hydrogen bond of HF is stronger than HO and HO is stronger than HN. But when we compare the boiling point of HF with boiling point of water, we'll find the boiling point of water is higher as compared to that of HF. What is the reason? Because in HF there is only one hydrogen bond between the two molecules. But here in case of water, there are two hydrogen bonds. Like each molecule can form two hydrogen bonds. That's why the boiling point of the water, even though its hydrogen bond is relatively weaker compared to that of hydrogen fluoride, but it will have a high boiling point. And NH3, it's having a like the weaker hydrogen bond, that's why it is having lower boiling point compared to. So when we compare the boiling point of H2O will be more than HF when we are comparing the boiling point, and HF is more than NH3. But when we compare the strength of the hydrogen bond, not overall, like each hydrogen bond. So hydrogen bond of HF is stronger than HO, and HO is stronger than NH. So molecules such as alcohols, carboxylic acid, amides, proteins, they can form hydrogen bond. So whenever they ask the question, and as I mentioned in the beginning, that these are the three type of forces are there which can exist. So you might have all three of the forces within the molecule, you might have two of them, or maybe only one of the forces there. Like example, if I say identify the types of forces in propanol. So we have to identify the types of the forces in propanol. And the best thing to understand the type of forces, you try to draw the structure. Prop means 3 carbon, and all means OH group is there, and then we complete with hydrogen. So this is propanol. Now always write a charge because oxygen is more electronegative. So oxygen will be partial negative, hydrogen will be partial positive. And this carbon will also be partial positive because oxygen is more electronegative, so it will have a greater tendency to attract. Now what kind of forces exist? So when we check, first thing, hydrogen is bonded with oxygen. So a molecule contain, whenever hydrogen bonded with oxygen, fluorine or nitrogen, so this may leads to what? This may leads to hydrogen bond. So this part of the structure leads to hydrogen bond. Then when we check the carbon chain, like carbon is there with oxygen, CO, but when we check, because oxygen is more electronegative, the CO may leads to, because there's a partial positive and negative, so this part of the structure leads to permanent dipole. And when you check the carbon chain, the two carbon atoms are there within the structure. They don't have partial positive and negative. So what it leads to, when we have no charges on the part of the molecule, so then it will leads to London dispersion force. So sometimes they ask like what will happen if the number of the carbon increase, what will happen if to the boiling point if it is branch. So the force, if the number of the carbon increase, the London dispersion force will increase. As the London dispersion force increase, so the boiling point will also increase. So in this case, we have permanent dipole hydrogen bond, but this bond, it's relatively like not strong permanent dipole for CO. Another example, if I say we have propanol or propanon. Propanon means ketone. Ketone refers to C double bonded with O. Like when a compound is having C double bonded with O, it's known as ketone. When we compare the type of the bonding which can exist, so we have carbon, prop means 3 carbon and on means there is C double bonded with O. So this will have 3 hydrogen atoms. this will have three hydrogen atoms. So when we check the part, so C double bonded with O, so this oxygen is more electronegative, so partial negative and partial positive. And there are carbon chains, because carbon chain between carbon and carbon, they don't have the induced like permanent dipole between the carbon atoms. So what it leads to, the bond between C and O, that leads to dipole force. And the carbon structures, three carbon are there. So what it leads to, this leads to dipole induced dipole force. So the one leads to dipole induced dipole and the other one is dipole. So in this molecule, the two forces can coexist, or two forces are existing at the same time, but you don't find hydrogen bond is not there until unless hydrogen is forming a bond with nitrogen, oxygen, or fluorine. Another example, like, so it is very important that you work out the types of the forces and relate them, because sometimes they ask C plus attract. Now, actually, this plus and C minus is due to oxygen. Oxygen and carbon have difference in the electronegativity. That's why partial positive negative. But this C plus will not affect the carbon-carbon bond, because they have the same tendency to attract the electron. So bond between them will remain non-polar. But the bond between the carbon and oxygen will turn into polar. So this bond will remain non-polar, and due to non-polar part, it will be dipole-induced dipole. And the carbon and oxygen part, that is the polar bond, so it will be dipole-dipole force. So when we compare, this is this table is very important, that you should be able to explain the idea of um, hydrides of group 6, group 7, group 5, and group 4. So when you check, first you have water. When we check group 6 hydrides, first we have water, then hydrogen sulfide, then hydrogen selenide. It's having, so first water is there, H2O. Water is having a greater boiling point than H2S. But what happened? H2S is having a smaller boiling point than H2SE. So what is the reason why it is not following a trend? Like first it is, so it depends on the intermolecular force. So when we have water, what kind of intermolecular force exists in the water? London dispersion forces are always there, because whenever you have electron, you will have London dispersion forces as well. So this will have major force will be hydrogen bond. That is a major force. And there will be London dispersion force. When you check H2S, and because oxygen is more electronegative than hydrogen, so hydrogen bond is there, and dipole force will be there. And London forces. When you check the second one, this will have only dipole forces, because hydrogen is bonded with sulfur. Sulfur is more electronegative than hydrogen. So there will be partial positive and negative, and London forces will be there. When London forces are always there, the reason is that, but considerable London forces, as a number of electron increases, they will have a considerable London force. So what happened? This will have a strong dipole, but weak London forces because the number of electrons are less. When we check hydrogen selenide, the third one, so in case of hydrogen selenide, the dipole-dipole forces, because electronegativity decreases as we go down the group, the electronegativity decreases. So electronegativity is less, but the number of electrons are more. In SC, the number of electrons are more, and as the number of electron increases, there will be a considerable change in the London forces. So overall, when we check them overall, we will find that overall forces in H2SE are stronger compared to H2S. Is it clear that why the boiling point of H2SE is more than H2S? So they asked this question that compare compare the boiling point. So when we are comparing the boiling point of water with hydrogen sulfide, so what are the reasons? We'll say water is having a hydrogen bond and H2S is having no hydrogen bond, and hydrogen bond is the strongest compared to any other forces like dipole-dipole, dipole-induced dipole. So hydrogen bond is the strongest in terms of intermolecular, but it is not stronger compared to covalent. Covalent is a intramolecular within the molecule, whereas hydrogen bonding is intermolecular. So when we compare water molecule with hydrogen sulfide, water is having a hydrogen bond, and that is stronger compared to no hydrogen bond in hydrogen sulfide. When we check the second option, hydrogen sulfide is less than hydrogen selenide. So what is the reason for that? Even though it is having stronger dipole-dipole, like here dipole-dipole is stronger, dipole-dipole is stronger, and London forces are weaker because less electrons. But in H2SE, dipole forces are smaller, as smaller difference in electronegativity, like electronegativity is decreasing. But the London forces, because there are more electrons, as increase in electron increases the London force. So net result of this change is more as compared to net result of this change. That's why the H2SE will have a higher boiling point. And this is valid for all the groups. As you can see, like this we are talking about group 6, but this is also valid for group 7. HF is there, then HCl, and after HCl this HBr. So why HF is more than HCl? What is the reason? Because this is having hydrogen bond, this is having no hydrogen bond. But why HCl is less than HBr? So even though they will have dipole-dipole force, but here the London forces in HCl are weaker as compared to London forces in HBr, as it is having more electrons. That's why the HBr boiling temperature is higher, and then followed by hydrogen iodide. But group 4 does not follow this trend. Group 4, why? Because group 4 does not have hydrogen bond. So they have only London dispersion force. Even they don't have dipole-dipole forces, as the molecules are not molecules are symmetrical. So as the molecules are symmetrical, they only have dipole-induced dipole force. And the dipole-induced dipole force increases as the number of electron increase. That's why the CH4 boiling point is higher than SiH4. SiH4 boiling point is higher than GH4, and GH4 boiling point is higher than SnH4. Is it clear? The concept of like the effect of these intermolecular forces on the boiling point. So this is a very important chart. You have to learn this, and you should be able to explain this chart in terms of intermolecular forces. Any doubt till this point?